Hello, it's Valentine from Simplistic, and we're going to take a look at how to find the pH of a acid solution out here. That's HNO2, that's the acid solution. And what we need to understand is this is not a strong acid, it's a weak acid. Therefore, we'll have to use the Ka of this acid, and we have to use an ice table to figure out what the concentration of H plus ions are, and then we'll find the pH. So let me kind of map out the process out here on the right hand side. So step one, we're going to uh, draw the equilibrium for HNO2. Step two, we're going to create the ice table. Step three, we're going to write out the expression for Ka. Step four, we're going to solve for X, which is going to be the concentration of, which is going to be the same as the H3O plus ion concentration. And then step five, we find the pH. All right, so let's go ahead and get into this. So let's draw the equilibrium out here. So HNO2 aqueous, it gives us H plus F minus. And initially, we have 0.010, 0 of H plus and 0 of F minus. The change is going to be minus X for all of them. And then at equilibrium, we're going to have 0.010 minus X for the HNO2. We're going to have, the change is going to be positive X for the product side. And at equilibrium, we're going to have X for H plus and X for F minus. So Ka is equal to H plus ion concentration times F minus ion concentration over the concentration of HNO2. Now let's go ahead and plug the values in. So first of all, we need to find what the Ka is from a table. So from a table, if I look up the value of Ka for HNO2, I get 4.6 times 10 to the negative 4. And then I'm going to plug in the values from the ice table for this part. So that's going to be X times X over 0.010 minus X. So what we're going to do is we're going to soon realize that X times X actually is X squared. So we really have to solve a quadratic. So let's make our assumption out here that this little X out here is really, really small, and it is much smaller than this term. So therefore, if you subtract this X from this, then the bottom is essentially equal to the same as just this by itself. So if you make that assumption and just scratch that X out, let's see where we get from there. And let's see if our assumption is valid. So if we do that, we get X squared is equal to, we're going to multiply both sides by this term. So we get X squared is equal to 0.0000046. Okay, and we take the square root of that, we get 0.0021. Now we have to test this assumption if that X is really small. So all we have to do to test this is take the X and divide it by the term we subtracted it from and see if that is less than 0.05. So let's do that. 0.0021 divided by 0.010. And that ends up being 0.21, which is actually greater than 0.5. Greater than 0.05. Okay, and because of that, our assumption is not valid. So what we have to do out here is we have to basically solve it the hard way, which means you have to solve the quadratic, okay, which was this equation. So let's go ahead and rewrite that and solve it. So if I rewrite that, I'm going to do 4.6 times 10 to the negative 4 is equal to X squared over 0.010 minus X. So I'm going to multiply both sides by this term. So that gives me X squared is equal to 4.6 times 10 to the negative 6 minus 4.6 times 10 to the negative 4x. And if I take all these terms and put it on the left, so I've moved the x to the left and then I switch signs and make the right equal to 0, I get x squared plus 4.6 times 10 to the negative 4x minus 4.6 times 10 to the negative 6 is equal to 0. Now the quadratic formula is x is equal to minus, let me just go ahead and preface that with, if I have a quadratic equation ax squared plus bx plus c is equal to 0, then x is equal to negative b plus minus square root of b squared minus 4ac, and the whole thing is over 2a. So I'm going to plug those values in out here. So essentially I need to understand that in this, my a is equal to 1, b is equal to 4.6 times 10 to the negative 4, and c is equal to negative 4.6 times 10 to the negative 6. All right, so once I have that, let's plug that in. So we get x is equal to minus 4.6 times 10 to the negative 4 plus minus square root of 4.6 times 10 to the negative 4 square minus 4 times 1 times negative 4.6 times 10 to the negative 6. And the whole thing is over 2 times 1. Now, let's go ahead and just simplify these terms. So the square term becomes 2.11 times 10 to the negative 7. And then this term, if you multiply it out, you get plus 1.84 times 10 to the negative 5. That whole thing is over 2. And now we're just going to simplify all of this. So if I take the square root of this entire term, I get plus minus 0.0043. I'm going to carry some extra digits out here just in case. And the left is, I'm going to just change this into standard notation so that we can subtract easily. 0.00046. Whole thing is over 2. Let's go ahead and simplify it out here. And that simplifies 2. So we have two options out here. If I take the negative of this and I take the negative of this number and divide it by 2, I still get a negative. So that answer is not going to be a valid answer because you can't have a negative concentration. But if I take the negative of this and I add it to the positive of this, then I get a positive answer. So I'm only going to go with that answer, with that option. So that gives me 0.000, sorry, just 2 zeros, 193. All right, so this is the concentration of H3O plus. So the pH of this is going to be the negative log of the H3O plus ion concentration. So if I take the negative log of this value, I get the pH is equal to 2.72. And there you have it. That is the pH of the solution of this acid with this concentration. I hope that made sense. Thank you for watching.